All right, so today we're going to be looking at voltaic and galvanic cells. So we're going to learn how to write half reactions using the electrodes, magnesium and zinc. The first thing we have to figure out is which of these electrodes are going through oxidation and which one's going through reduction. And to figure this out, which way the electrons are flowing, is it flowing from magnesium to zinc or is it flowing from zinc to magnesium? We're going to have to use table J to figure this out. Table J shows you a list of metals that are the most reactive on the periodic table. So I'm just going to circle for you zinc, which is Zn, and I'm going to circle magnesium. The way you know which one is most reactive, you follow the arrow. Most active is all the way at the top, least active is all the way at the bottom. If you open up the chemistry reference table, you could have a better picture of this. Again, it's table J. So with that being said, magnesium is most active, which means magnesium will want to lose electrons. Again, the most active metal loses electrons. So that tells me, I'm going to draw an arrow here, that electrons are flowing from magnesium to zinc through these wires, which means magnesium is going through oxidation. So there's oxidation happening at magnesium. And then there's reduction happening at zinc because zinc is collecting all these electrons. So if it's collecting all these electrons, that means it's going through reduction. So let's go ahead and see if we can answer these questions. Determine the flow of electrons between the two electrodes. And right away, we see that because magnesium is the most active, because it's above zinc, we can say that electrons, let me just erase this stuff. I don't know how to get these to work for some reason. Electrons flow from magnesium to zinc. Next question says, which electrode is the cathode and which is the anode? So if you remember from our previous lesson, the cathode is where reduction happens. So the zinc electrode is where is a cathode. How do we know this? Because reduction happens at the cathode. Which is the anode? It's the obvious answer. Magnesium. So magnesium, so Mg electrode is the anode. Oh, I misspelled here. And we know that oxidation takes place at the anode. Okay, let's move to number 3. So if the porous barrier is acting as a salt bridge, what is the purpose of the salt bridge? So if we're having all these electrons, these negative electrons move from magnesium to zinc, we need to neutralize them, right? So the salt bridge allows for the flow of ions, free flow of ions. And that's this porous barrier right here. I'm going to circle it. This is the salt bridge. And it's also labeled, but I just wanted to take the liberty of showing it to you. All right, next question. Write a balanced half reaction equation for the oxidation that occurs in the operating cell. Well, we know oxidation is happening in magnesium, right? So that's Mg. Arrow and it becomes Mg, well, you can see it becomes Mg2 plus. It tells you in the equation, right? Mg2 plus. And I need to know how many electrons it's losing. This oxidation number told me I can know right away that it lost 2 electrons. So it lost 2 electrons. And we're representing electrons using the little symbol E with a negative sign because electrons are negatively charged. Write a balanced reaction, half reaction equation for the reduction that occurs in the operating cell. Now zinc, on the other hand, Zn2 plus, and I'm copying this exactly how I see it in the equation. I'll show you that in a second. Gains 2 electrons, and it became Zn0 or zinc 0, zinc that has no charge. Now your question might be, how do I know when to put the charge or when not to put it, and which side should I put them? By charge, I mean oxidation numbers. Just look at the equation. I want to show you that magnesium 0 is on the left of the arrow. I have it on the left of the arrow, right? Magnesium 2 plus is on the right of the arrow. I have it on the right of the arrow. I'm use a different color. I use red for zinc 2 plus is also on the left of the arrow. So I kept it on the left of the arrow. And then zinc 0 is on the right of the arrow. And that's what I did. I kept it on the right side of the arrow. So I'm basically just copying exactly how it is on each side of the arrow. I just need to figure out how many electrons am I going to put on each side. So that's what you guys need to figure out. And you're looking at the chart, the oxidation numbers to figure this out. All right, so let's use this to complete the worksheet. Classwork 4.8 from last week. I believe there are, let me just clean this up. There are two questions for you to practice. Just watch my video a couple times and you should be able to master this. All right, have a great day, guys.